Hey, welcome to Chemistry with Miss E. If you are on the topic of writing formulas for ionic bonds, give yourself a pat on the back because you have hit almost the peak of your chemistry class. This is a very important skill that you need to have to continue to be successful in chemistry. I tell my students that this is one of the top 3 skills that you have got to be able to do is writing formulas and writing names, which will be another video, for ionic bonds, okay? So let's talk about it. What is an ionic bond? Hopefully you do know, but if you don't, that's okay. Ionic bonds are between a metal and a nonmetal, okay? So when you have a metal, such as sodium, right, and a nonmetal, such as chlorine, right, when they come together and bond, you get sodium chloride, right? That's an ionic bond, okay? And again, just to emphasize, right, metals are from the left side of the periodic table all the way down to the bottom of this staircase metalloid ladder. And then your nonmetals are the elements that are above and to the right, that staircase ladder, okay? So majority of the periodic table is metallic, right? They're metals, but you do have this percent up here that is nonmetals, okay? So when you have a metal and a nonmetal from those regions coming together, that's an ionic bond, all right? And whenever you put an ionic bond together, you have to deal with the ions, right? And ions are charges. Every time you hear the word ion, you should think charge every single time. And you can see it's even in the name, right? An ionic bond, literally the root word is ion, okay? So you have got to deal with charges. There are 2 methods that I'm going to show you. One's called the drop and swap or swap and drop. It works really well as long as you keep your eye out for a few things. And then there's also the T-chart method, which is really showing your work to the most intricate detail, not necessarily like needed for majority of problems, but I want to show you both ways just to have extra visuals, okay? So here's what happens. Whenever you put a metal and a nonmetal together to form an ionic bond, you cannot assume that they just go together in a 1-to-1 ratio, right? For example, if I'm trying to combine aluminum and chlorine, right? If I want aluminum as my metal and chlorine as my nonmetal, these do not cancel out. Like they don't fit, right? Aluminum has a +3 charge. So I tried to draw like a quick little visual here, like 3 + 1, right? +1 little boxes here. And if I'm trying to put chlorine with it, chlorine's only -1, right? And so these don't cancel out. This does not work if I were to just write AlCl. Absolutely not. Don't do that. That makes every chemistry teacher's heart break, okay? Do not do that. You have got to balance the charges, and here's what I mean by that. I'm going to put aluminum here as a +3, right? How do I know it's a +3? Let me show you on the periodic table. There is a pattern, there is a trend to the charges, +1, +2. Transition metals, I call them the fake people of the periodic table. They act different depending on who they're with, right? So their charges change, okay? Don't worry about transition metals for right now. We have +3, ± 4. The -4 is because of carbon, but everything else down here is going to give you a +4 category. -3, -2, -1, and 0. Okay, those are the charges. So that's what I always have to pay attention to. So make sure you have your periodic table handy and ready to go if you don't have the ion charges memorized already. So aluminum is a +3 charge because aluminum is here in the +3 group, okay, group 13 on the periodic table. And then you've got chlorine. Chlorine is a -1 charge. Again, chlorine here, -1 charge in the halogen column, okay, group 17. So when I put these 2 together, if I do the drop and swap, is what that's going to look like is we are going to turn these exponents, right, per se the charges, and we're going to get, don't worry about the plus or negative, okay, that part doesn't matter, but the 3 would come down to the chlorine and the 1 would come down to the aluminum, okay? Again, I'm not worrying about the plus or the minus sign because we're actually, when we say that we have a subscript of something, for example, Al, right, let's just say I have 3, that's saying I have 3 aluminums. I couldn't say -3 aluminums, right? That's like antimatter. That's like matter that doesn't exist. That's like going back in time type of stuff, okay? That doesn't work. You can't do a negative number. So it's going to be Al, bring that 1 down. We don't write 1s in chemistry, so it's just going to be Al, right? It's assumed for, it's on your paper. And then I'm going to write Cl and 3. So again, I did the drop and the swap, okay? The exponents became the subscripts when I'm writing my formula. And this would be my answer, okay? I would double check and make sure that I can't reduce my subscripts, right? So aluminum is a 1 and chlorine is a 3. I can't reduce 1 and 3 further, so that is my final answer and we're good. So again, you can see here if chlorine were to have 3 chlorines, right, which we do in the formula, then I have a -1, -1, -1, and now these 2 pictures, right, they cancel out, they match, okay? It's a perfect match. If I did the T-chart method, I would do aluminum as a +3, right, and that would be a +3 total on the left-hand side. Chlorine is a -1. I need -3, right, to cancel out the +3, so I have to add another chlorine, that's -2. another chlorine, -3. So you can see here, aluminum, one of them, 1, 2, 3 chlorines, right? And so there's the T-chart method, showing it in a very intricate way, and this was using the swap and drop method, okay? Let's go ahead and practice some, just so that you can, get more comfortable with it, because this again is a top skill. Like, you have got to know how to do these correct every single time, because you're going to be doing this as a first step when it comes to future lessons and topics and units, okay? So we're going to write the formula for the following ions, assuming that they combine into an ionic bond, okay? I have my cation in the first column here, and then I have the anion in the second column here. We're going to combine them, though, going across, and we need to account for the charges, right? So when I say Li and O, I can't just put LiO, right? I cannot assume that they just come together in a 1-to-1 ratio. You have got to look at the charges. You have to balance them out, swap and drop, and do the specific steps, okay? This is a very, very important. So lithium, I'm going to go to the periodic table and find the charge of lithium. Lithium is over here. It is a +1 charge, okay? And oxygen, finding oxygen on the periodic table, that is a -2 charge, okay? So Li +1, O -2. So again, dropping and swapping. The 2 comes down to Li. The 1 goes to the oxygen. So it's going to be Li2O, right? So there you go. Li2O is your final answer here. Let's do another one. Let's do Ca and S. So find them on the periodic table. Calcium is a +2 charge on the periodic table. And sulfur on the periodic table, right? Sulfur has a -2 charge, okay? Sulfur is a -2 charge. Oh, +2, -2. I could drop and swap, but then I would have Ca2S2, right? And can I reduce 2? Absolutely. 2 can be divided by 2. So really, the formula that you're going to write is going to be CAS. So when they cancel perfectly like that, don't write the subscripts, okay? It would just be the element symbols on their own. So there you go. You have CAS, all right? Al and Br, okay? So we're going to find these on the periodic table. Aluminum has a +3 charge, okay? And bromine has a -1 charge, okay? Bromine is in the -1 spot. So what would we do? Drop and swap. The 1 comes down to aluminum. The 3 comes down to bromine. Again, don't write 1s, okay? So it's just Al, and then I would say Br and the 3, okay? And that balances that one out. All right, let's do the next one. I have Fe. The charge is given to you here because iron is a transition metal. What I mean by that is it is in the transition metal area of the periodic table, and again, the charges can change, okay? So iron could be a +2 one day and then a +3 the next, okay? So there, your teacher would need to give you some sort of understanding to know what charge you're working with, okay? Otherwise, I guess just pick one and roll with it, but for the most part, it should be provided to you if it's given to you in this format. Fe has a +2 charge here, okay, and nitrogen, finding it on the periodic table, has a -3 charge, okay? So again, I'm going to drop and swap. The 3 comes down to the iron, and the 2 goes to the nitrogen, and so this is going to give me Fe3 and 2. Got it? Can 3 and 2 reduce any further? Absolutely not, right? That is my final answer, and that's good. If you notice in this pink-red color down here, I did include some polyatomics. If your teacher has worked with these already, then that's awesome. But polyatomics, poly means many. Atomic is atom, so it's many atoms, okay? So you can see we have way more capital letters here, right? Every time there's a capital letter, that's a new element. So I tell my students, as soon as you see more than 2 capital letters, you have a polyatomic in your problem, okay? Everything we've done up here and so far only had 2 capital letters total, right? 2 capital letters, 2 capital letters, 2 capital letters, 2 capital letters. But you can see here, I have 1, 2, 3, 4 capital letters, so I actually have 2 polyatomics, okay? Polyatomics, for most chemistry students, they're provided to you on a periodic table formula page of some sort, or your teacher or professor might be having you memorize them. That's great too. Make sure you get started on memorizing your polyatomics if that's required of you. But NH4 plus, right, that has a +1 charge. This is ammonium. And then I have NO3 minus, okay? These are a +1 and a -1. Again, we don't really write 1s in chemistry or math. It's assumed for. But NH4 plus and NO3 minus, I see that this is a plus and a minus charge, so they actually cancel out, okay? This is a +1, -1, so it cancels out. I'm just going to combine them just as they appear. So NH4, NO3. So that's ammonium nitrate is what that would be called, okay? All right, moving along to our last problem here, we have Mg. Mg on the periodic table, I'm going to find the charge, and that is a +2 charge, okay? And ClO3 minus, this is another polyatomic, okay, chlorate, and that's giving us a -1 charge. So if I drop and swap, because I have to, they don't cancel out here, my 1 would come to magnesium, and my ClO3 actually would need a 2. Now I'm not going to write ClO3 2. That looks so weird. Then I'm saying ClO32, right? Absolutely not. We do not want to do that. So how can I say that I have 2 ClO3s? Parentheses. If you said parentheses, you're doing great. So Mg, right? Again, the 1 coming from the chlorate, so just write Mg, and then parentheses, ClO3, parenthesis 2, all right? And that's how you say that you have 2 of something. So make sure you use parentheses when you're dealing with more than one polyatomic, okay? It's not standard protocol to put parentheses around polyatomics unless you have more than one of it, okay? So just keep that in mind and watch out for those. All right, see ya on the next one. Bye.